Okay, in this lecture we will discuss about the image parameters. So image parameters are generally used in the design of filters which specify the properties of filter sections, and they are nothing but image parameters. So there will be different parameters in this. We will see what are these one by one. First of all, before that we will see what is a section means. So a section consists of at least one shunt component and at least one series component. So with this you can understand there will be several sections like T sections, pi section and L sections and all. And with this we have unbalanced networks as well as balanced networks. So and we also have ladder networks where different sections are connected in cascade manner so that it looks like a ladder. They may be 2 or 3 T sections or L or pi sections which are connected together in cascade manner so that they will look like a ladder. And in those ladder networks we can have either unbalanced ladder network or balanced ladder network. So here if you see this this section where several T sections are connected in cascade manner, so this is unbalanced. So in order to make this balanced, we need to have one more series arm resistance connected in downwards. Okay, so this is a kind of H section which is balanced. Since there are no series arm resistances towards the lower side, this is unbalanced and this is balanced. Right? Okay. So now let us see the first image parameter, that is image impedance. Right? So we will see what is this image impedance, and the importance of this image impedance will be understood in the latter lectures. Okay, let us see now how to define image impedance and based on which how we can derive it. So if you see image impedance in a two-port network, if the impedance seen from port 1 is Zi1 when the port 2 is terminated by Zi2, and if the impedance seen from port 2 is Zi2 when the port 1 is terminated with Zi1, then Zi1 and Zi2 are called image impedances. So from this you can understand there are two cases. Case 1 is there and case 2 is there. So here in case 1 you can see so this is case 1, let us say, and this is case 2. So what is there in case 1? In case 1 the impedance seen from port 1 is Zi1 when port 2 is terminated with Zi2. Whereas in case 2 the port 1 is terminated with Zi1 and port 2 is seen with an impedance of Zi2. If this happens for any network, those Zi1 and Zi2 are called image impedances of that particular network. Fine, that means the image impedances are two for they are defined based on two different cases. Why they are defined like this we will be understanding in the other lectures. We will see them. Fine. Now in order to derive these Zi1 and Zi2, we need to consider these two cases and get equations and then solve them, because we will get two equations in two cases and there are two unknowns which are Zi1 and Zi2. We can get them from those two equations, right? So okay, first we will be looking into port 2. Let us look into port 2, that is case 2. For this case 2 you can see Zi2 is equal to V2 by I2. From this we can write V2 is equal to plus Zi2 I2. But for the same case 2, if you consider Zi1, Zi1 is equal to minus V1 by I1. Why this is minus? Because generally Zi1 is impedance and it is a passive element. So for passive element the convention of current is entering. But here if you see the I1 is leaving the Zi1, that means it should be opposite. That's why we wrote Zi1 is equal to minus V1 by I1. This is very important point here. Right, now we will be deriving ZI1 and ZI2 in terms of ABCD parameters. So it is chosen like that because generally in transmission line these parameters are used, right? So then you write the equations of ABCD parameters, then if you rearrange them like this, and then if you solve them, so you solve these two, then you will get ZI2 value, which is nothing but V2 by I2, right? So ZI2 you got in terms of ABCD parameters, but that is in terms of ZI1. That means anyways we got one equation. Now what we do, we will be looking into port 1. Looking into port 1 means it is for case 1. So let me clearly write, this is for case 2. First point is that you don't combine the equations of case 2 and case 1. There are separate cases and each case will be used for getting one equation. So these equations are for case 2. Now when you look into port 1, this will be for case 1. So in a similar manner you rearrange the equations of ABCD parameters, then get ZI1 in terms of ZI2 and ABCD. Fine. So like this you will get ZI1 and ZI2, which are given in equation 1 and equation 2. Now we have unknowns of ZI1 and ZI2 here because ABCD parameters are known for any given network. Yes or no? Yes, ABCD parameters are known. You can even find any other parameter for a given two-port network. So they are known to us. So only unknowns are ZI1 and ZI2, and they will be solved using 1 and 2 here. Right. So first you need to substitute 1 in 2. Then you will get ZI1. So ZI1 is this one. Fine. Similarly, you need to substitute 2 in 1. Then you will get ZI2. See, ZI1 is square root of AB by CD, whereas ZI2 is BD by AC. Fine. So this is about ZI1 and ZI2, which can be determined using ABCD parameters. Right? Fine. So in the next class, we will see the determination of ZI1 and ZI2 in terms of open circuit and short circuit impedances. Fine. Okay. Thank you.